The animal of the day, May 19th, is the extinct Meganeura. Type: insect. Diet class: carnivore. Average lifespan, estimated to be 1 to 3 years. Size, up to 14 inches or 35 centimeters in body length. Wingspan, up to 26 inches or 66 centimeters. Weight, likely up to 2.5 ounces or 70 grams. Population status currently May 19, 2025, extinct. Population estimate, none, extinct. Native lands, modern-day Europe. Primary habitat, tropical coal swamp forests. Main predators, early amphibians, tetrapods, other large arthropods, and fish. Diel activity, likely diurnal. Genus age, emerged approximately 305 million years ago and extinction occurred to 199 million years ago. Notes: Meganeura is an extinct genus of insect from the late Carboniferous period among the extinct Meganisoptera order known as the griffenflies, who were closely related to and resemble dragonflies and damselflies. The Meganeura genus contains one fully recognized species, Meganeura monyi, who is the type species and is one of the largest known flying insect species, as well as Meganeura brongniarti, who is debated on whether it is a species or just a synonym of monyi. Research on close relatives Meganeurula and Meganeurites suggest that Meganeura was adapted to open habitats and was similar in behavior to extant hawkers. The Meganeura likely had eyes that were enlarged relative to body size, and they had spines on the tibia and tarsi sections of the legs, which would have functioned as a flying trap to capture prey. Studies indicate that Meganeura typically lived near the edge of bodies of water such as streams and ponds, likely preying upon other insects, small amphibians, and vertebrates. The way oxygen is diffused through the body of an insect via its tracheal breathing system puts an upper limit on body size, which prehistoric insects, including Meganeura, seem to have exceeded. It was originally proposed by French paleontologist and paleoentomologist Henry Harrel that Meganeura was able to fly only because the atmosphere of Earth at that time contained more oxygen than the present 20%. However, this hypothesis was initially dismissed by fellow scientists, but has found approval more recently through further study into the relationship between gigantism and oxygen availability. The presence of very large Meganeuridae with wingspans rivaling those of Meganeura during the Permian period, when the oxygen content of the atmosphere was already much lower than in the Carboniferous period, presented a problem to the oxygen-related explanations in the case of the griffenflies. However, despite the fact that Meganeurids have the largest known wingspans, their bodies were not very heavy, being less massive than those of several living Coleoptera, and thus were not true giant insects, only being giant when compared with extant relatives. Another explanation for the large size of Meganeurids compared to extant relatives was brought forth by German paleoentomologist and evolutionary biologist Dr. Oliver Beckley, who suggested that the lack of aerial vertebrate predators allowed pterygoid insects to evolve to maximum sizes during the Carboniferous and Permian periods, perhaps accelerated by an evolutionary arms race for an increase in body size between plant-feeding Paleodictyopter and Meganisoptera as their predators.